Welcome to the Explainer. Today, we're going to take a quick tour of MATLAB. It's this incredibly powerful tool that millions of engineers and scientists use every single day to bring their ideas to life. So let's just dive right in and see how it tackles one of the biggest challenges out there. I mean, think about it. This is the problem at the heart of pretty much every field of science and engineering. You're just flooded with data points, right? But what you really need is to understand what's going on. You need to see the pattern, find that signal hiding in all the noise, and then, make a decision. That exact problem, that's what MATLAB was built for. So what is this thing, really? Well, yeah, it has its own programming language, but it's so much more than that. You should think of it as a complete interactive environment that's designed from the ground up for technical computing. Everything from a quick back-of-the-envelope calculation all the way up to developing these massive complex simulations. So what does that actually look like? Well, honestly, it's used for just about everything. You might use it to pull apart the signals coming into a radio receiver, or maybe simulate how gases behave under different pressures. Or say you've got a bunch of messy data points. You could use it to perform a linear regression to find the real trend in there. It absolutely crushes complex systems of equations, and maybe most importantly, it helps you visualize your data in ways that just make the answers leap off the page. The best way to really get a feel for MATLAB's power is just to see it in action. So let's write our very first program, and I promise it is way simpler than you think. This is where the magic really happens. That's it. Seriously. Just 3 lines of code. The first line, that just creates a series of numbers from 0 all the way to 6. The second line calculates the sign of all of those numbers. And the third line, well, that just tells MATLAB to plot them. And boom, this right here is what I'm talking about. This is the core strength of MATLAB. Those 3 simple little lines produce this detailed graph just instantly. There's no complicated setup, no pages of boilerplate code. It's just a straight line from your idea to a visual result. So how did that happen so fast? Okay, step 1 defined our data, and step 3 plotted it. But the real magic is in that middle step. See, MATLAB didn't loop through the numbers one by one to calculate the sign. Nope, it did the calculation on the entire set of numbers all at once. And that ability is totally central to everything you do in MATLAB. This whole do-everything-at-once approach is possible because of one fundamental concept that MATLAB is built on top of, the array. This is really the secret ingredient, the thing that makes it so fast and so intuitive for all kinds of technical work. So what's an array? It's really just a collection of data values, all organized neatly into rows and columns. And here's the thing, just about every variable in MATLAB is an array. The entire environment is designed from the ground up to think in terms of these collections of data. And that's what makes operations on huge datasets so incredibly efficient. The simplest kind is a 1D array, which you'll often hear called a vector. You can just think of it as a simple list or a single row of numbers. Actually, in the code we just wrote, both x and y were vectors. Now, if you add a semicolon, you tell MATLAB to create a new row. And just like that, you've turned your vector into a 2D array, which we call a matrix. It's basically like a grid or a little spreadsheet. This super simple but really powerful structure is the foundation for handling everything from images to the guts of a complex system of equations. Okay, so we've got our data, it's organized into these powerful array structures. So now we can get back to what's arguably the most important part, turning that raw data into actual insight through visualization. And this slide right here shows that transformation perfectly. On the left, that's our quick and simple plot from before. It's great for getting a first look, seeing if you're on the right track. But on the right, that's a publication-ready graph. It's got a title, labeled axes, a legend, even a fitted line. MATLAB makes it so easy to go from that initial exploratory sketch to a polished professional figure. And you have total control over everything. You can add titles and labels, tweak all the colors and line styles, use different markers for your data points, create legends, add grid lines, basically everything you need to tell a really clear story with your data. And then, when you're done, you can export it in high-quality formats like PNG or TIFF for your reports and presentations. Of course, most real-world problems need more than just a few lines of code. So how do you organize all these commands into bigger, more powerful programs? Well, MATLAB gives you 2 main ways to do it, scripts and functions. A script file is pretty much what it sounds like. It's just a collection of commands, exactly like the ones we've been typing. It's awesome for quick, one-off tasks. A function, though, is a much more robust, self-contained little program. And the really crucial difference is that a function has its own private workspace. It only sees data that you pass in as inputs, and it only sends data back through its outputs. This makes functions perfect for creating reusable, testable tools that won't accidentally mess with other parts of your code. You know, ultimately, learning a tool like MATLAB isn't just about learning the syntax. It's about adopting a structured way of thinking, a systematic approach to breaking down and solving really complex problems. Anybody who has ever tried to build anything knows this feeling deep in their bones. It's just a universal truth of creation. Your first attempt is almost never going to be perfect. The source text puts it perfectly. Errors or bugs are going to happen. The real skill is in the process of debugging, of systematically hunting down and squashing those bugs. And that's where having a formal process becomes your absolute best friend. This is the kind of design process they teach in engineering courses everywhere. Before you write a single line of code, you clearly state the problem. You figure out exactly what data needs to go in and what information should come out. Then you design the step-by-step logic, the algorithm. Only then do you translate that logic into code and, of course, test it to make sure it actually works. And that right there is the key takeaway. MATLAB isn't just a language or a piece of software. It's a tool that really enables this powerful, systematic way of solving problems. It gives you all the building blocks you need to build, test, and visualize your way to a solution. This whole systematic approach is how we tackle some of the world's biggest challenges, from analyzing massive climate data sets to designing the next generation of wireless technology. And it all starts with just a few lines of code. So, the only question left is, now that you've seen the tool, what problem